Hello there, Khaled Al Malawani here. Today we're going to talk about the operating the ultrasonic sensor as well as the servo motor on the illegal car kit. But note that this can apply to any ultrasonic sensor as well as any servo motor. So let's get started. Before we jump into the code here, the first thing we should note and take in consideration is the data sheet. So the data sheet is quite an important document that's available if you just search up the name of the device or the sensor or whatever you're currently using and add data sheet at the end of it on Google per se, then you will find the data sheet that you need here. Now, you actually should be looking for is the voltage because your Uno as well as your Mega do have two different voltage inputs. There is the 5-volt input as well as the 3.3 volt input. Some Arduino, such as the MKR series, only has 3.3. If I think the Do also has only 3.3, but I do not remember the Do out of the top of my head. But the Uno has 5 volts and 3.3. So that's why it's important to, especially before you buy your sensor, it's important to see the voltage that it works in. Because in this case, for example, the servo works in only 4.8 to 6 volts. That means if you have a 3.3 um, microcontroller, you cannot power it from the microcontroller right away. You probably have to have an external source for it. Another thing to know about the data sheet is it includes a small text about the actual operation of it. So in this case here, it says servo can rotate approximately 180 degrees, which is 90 degrees in each direction. And that's exactly how a servo motors work. You set the degrees of it and it will move to that direction. Another thing to note is the ultrasonic sonar distance datasheet. This one's provided by Adafruit. In this case here, you can see that there is quite a few details as well, including the dimension of it. An important thing to note about the ultrasonic sensor is the measuring angle. The measuring angle of ultrasonic sensor is not straight. It's not straight ahead. It's actually at 50 degrees. So anywhere between the 50-degree range, if anything is between that, depending on the distance it is, of course, as you go further, the 15-degree range from the ultrasonic sensor is bigger. So anything within that range here will be detected. This device operates at, for best results, operates at 5 volts as written right here. This can work on a 3-volt device or a 3.3-volt device just by using the appropriate resistors. In this case here, it's also stated that this will operate from 2 centimeters to 400 centimeters, but it is better to use it for within a range of 10 centimeters to 250 centimeters for the best results. So this is the two important information that we can know from this data sheet here. It also has a few pictures of the actual device. So these two data sheets here are quite simple. They're quite straightforward. As you work with more sensors, there is more information that you probably need, such as, for example, the MPU 6050. You might need the data sheet for that, or the other various sensors that you might have. Also, it is quite useful to just look for a data sheet and see a lot of different data they have. In many cases, data sheet also includes example projects or example codes, and you might find that useful for your needs. Now let's go into the Arduino code itself. So in this case here, this is the Arduino ultrasonic sensor and servo reference code. So what this one will do is it will rotate the servo to the right at the very beginning, and then it will print out the distance of 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 what the ultrasonic sensor is detecting in centimeters based on its current location. And it will do the same. That would be, and then it will change direction to the midpoint after 5 seconds, and then it will go to the left side after another 5 seconds. What you will need here is just pretty much everything that's included in your legal car cage. You do not need anything extra. As long as you have all your components properly, then you're set to go. If you do not have an illegal car kit, then you just need a microcontroller, whether it's the Mega or the Uno. You also need the ultrasonic sensor and the servo motor. The ultrasonic sensor is the ultrasonic sensor is connected to pin 3, while the ultrasonic sensor is connected to pin A5 and A4, while the servo pin is connected to pin 3. These can be seen from your constant integers here. For the servo specifically, you do need to include the servo library, which if you remember from our tutorial on setting up the Arduino software, that you have to make sure that you have it downloaded from the manage libraries. It is usually pre-installed, so there's no big issues with that. And then after we do that, we can just declare a servo object from the servo class that we just, of which we just imported the servo library from. In the actual setup function here, we initialize the serial communication to be able to print out the data from the ultrasonic sensor to the serial monitor. We attach the servo to the servo pin, which means we're pretty much saying that to the microcontroller that at servo pin, which means at pin 3, there is a servo. That's pretty much what it's saying to the microcontroller. And then we declare here two pin modes. One is the trigger pin, the echo pin, and that will be for the ultrasonic sensor. The trigger pin will be the pin used as the output, so the one that sends in an ultrasonic wave out, and the echo pin will be the one used as the input. And then we start by setting the angle of the servo to 0 degrees, which is just the right side of the robot. As noted from the data sheet, you can set the angle to anything from 0 to 180. That will work for the servo. It's based on the degrees of operation. If we go into the actual void loop here, where millis is a function, is a predefined function in Arduino that pretty much records the current instance of time since you started the Arduino. That means since you turned on your microcontroller, then it has been working for a set of time. What millis does is it reports that time to you. Okay. Now the millis function, I think we'll keep going for, I think it was 85 days. You can double check by yourself through online just by searching for the millis function for the Arduino. So this is the millis function here. We just have a simple if-else statement here. So if millis is bigger than 10,000 milliseconds, so that is 10 seconds, then we can go and set the ultrasonic sensor to 180 degrees, so the left side. While if it is bigger than 5,000 milliseconds, we can set it to 90, so that is the midpoint. Clearly, if we think of this logic here, this one will go first, so we'll set it to midpoint first, and then this one will go next, and it will stay like that until you reset it. So that, and then we'll go to the left side. If we actually look into what we're printing here, we're printing the ultrasonic distance in centimeter function. What this does is it returns a long, as we can see here, and it has no parameters. It's quite simple. So it writes, first of all, a digital writes for the trigger pin a low. So that means that pretty much you're trying to send in a pulse, right? That's how the pulse in works at the bottom here. So what the pulse in detects is, as the name implies, impulse. A pulse is anything that turns on and off rapidly. So anything that goes and turns on and off rapidly is a pulse. So that's what we're trying to simulate here. So the trigger pin is trying to set it to go off first, and then that waits for 2 microseconds, and then it sets it high for 10 microseconds, and then it sets it low again. So that just created a pulse here. And then what the pulse in does is it declares that through the echo pin, it wants to detect it when starting at high. That's what the high signifies here. So the pulse waits till echo receives a high signal, okay? And then after it receives a high signal, it will keep counting, and then it stops counting after it receives a low signal. So now what we have here is the time. So we have the time of operation from the ultrasonic sensor going to the object and coming back. And with the speed of the ultrasonic sensor is preset, as well as the conversion to centimeter is preset by this number 29 here. So if you divide the duration, which is the duration of the time, divided by 29, that will account for the speed as well as the distance in centimeters. And then we divide it by 2, because the distance going forward and coming back is accounted for in that 29 here. All we need is just the distance, right? So we don't want the time going forward and back. We just want that divided by 2, and that will just account the distance from the robot to whatever object you're currently pointing at. So this is, and then it returns the value as a long. If you remember, a long is just a bigger integer. That is simply how the code works. It's quite simple. And let's get started by uploading it. And I'll just bring the ultrasonic or the illegal kit here to the camera. So it's compiling sketch, it's uploading, and then it's done uploading. As you can see, it's starting on the right side. And then after 5 seconds, it'll go to the center. And then after another 5 seconds, it will go towards the left side. If we start the serial monitor, it will reset it. If we start it, and then it will start on the right side. As you can see, it detects about 100. If I pull my hands closer back, in this case, my screen here is about 15 centimeters away. And then it detects from the left side. And then if I pull my hand, you can see the value changing. So you can see how far it detects. It's currently, my hand is away, so it's not detecting anything. Something to note about the ultrasonic sensor is that the materials detecting is important. If you're detecting fabric, it usually lags a bit. If you're detecting anything that is solid or is reflective, such as a screen is quite reflective, so there won't be an issue with that. Leather is quite reflective. Your hand is decently reflective. So you have to make sure that anything that you're trying to detect is reflective. Now, having said that, the ultrasonic sensor is quite powerful and it doesn't have to be quite reflective, such as a mirror, for example, but it is more accurate, or you get less lags, or you get less errors when it is reflective. That is just one thing to note. It's not too big of a deal. And that concludes the operation of the servo as well as the ultrasonic sensor. Best of luck on your coding endeavors, and I hope you found this video useful.